Welcome back everyone, my name is Jason Koo, and today I want to expand on the last video I did that was showing how to use BAML to take unstructured text and turn it into Cytoscape graph compatible JSON data, and then visualize it, interact with it through a Streamlit app. So I want to expand on this by adding in the ability to store that graph data into a Neo4j database, and then also to pull that data back out and again interface through a Streamlit app. Okay, so here to review the Cytoscape JSON data format, we've actually got two options that I didn't realize from before. On the left is what they call keyed by group. So this is a dictionary with the elements required key, and inside that there's the nodes and edges keys. Each has to be a list of dictionaries, and the dictionaries must have a data key in itself. This is the format also used by NetworkX, and this is what I'll continue to use in this video. But the flat file option on the right, this is what's used by the Cytoscape plugin used to visualize the graph data in the Streamlit app. And it just takes a flat file. So how it knows the difference between nodes and edges is if the data payload has just an ID, or if it has an ID and source and target key values, in which case then it's an edge. Okay, jumping into code, here I've made 3 changes compared to the previous code demonstrated. The first change was done to the graphs.baml file. Here, I hadn't realized, but I made a mistake in the syntax and formatting for the Cytoscape JSON format. I forgot to put the elements as the highest level key value. So here I just corrected that. So here I have Cytoscape graph, and it just has elements, and inside the element is the nodes and edges, which will turn into, elements, nodes, and edges nested. And I also corrected the nodes and edge data descriptions to make sure that they properly matched, right? ID, and then for edges, ID, source, and target as a minimum. And then here, the label is, so in Cytoscape, it by default uses a label property to identify like the display name for a node. But here in Neo4j, labels are used to define the categorical type of nodes. So here I made it match the type of entity. So this is going to match more of the Neo4j space. And then I have a property name, which I'm going to use for the display name. And then same for the edge here, label, I'm going to use that as the relationship type, which is what's used in Neo4j to differentiate relationships. And also the Cytoscape package, I'm going to use the label as the display name for the edge. Okay, here in a new app with Neo4j Python file, this is almost an exact duplicate of the prior app.py file, except in between where we're extracting all the data from BAML and then putting it into the session state, just making a call to upload data to Neo4j. So here I put the upload Cytoscape to Neo4j function into its own Python file, just for clarity. It has arguments for taking in the Neo4j credentials, and then the Cytoscape data as a string or a dictionary object. These are functions I had built before, and I was just making them general purpose, so I could just pass in stringified JSON or a proper dictionary object. Here at the top, I have kind of a kludgy way of verifying that we've got credentials information to use. All right, and then down here, we've got the initialization of the driver and the context manager. This is where we're passing the credentials. And then I have another simple check for the Cytoscape data. Probably could have moved this elsewhere. And what we're going to do here is we're going to take all the data from that list of dictionaries and just kind of simplifying it. So instead of having it nested into a data key value, just going to get rid of the data key and move all all of its values up into the upper level dictionary. So, all right, down here at the query, so we're going to pass this list of dictionary objects to Neo4j's Python driver. And this unwind statement basically is telling the driver to go through each of the objects. And as it does so, it's going to check to see if a node with this ID already exists. If it doesn't, it will create a new node. If this node already exists, it'll just kind of skip past this part. And then what we're going to do is we're going to call APOC which is a plugin. This plugin is automatically built into all Cloud and Aura instances of Neo4j. But if you're using desktop like me, then then to make sure you have it on, just click on whichever database you have running, click on the plugins, and open up the APOC option. If it's added, you'll have this uninstall button. If it's a brand new database, then you'll see a install button. The database has to be off when you install it, but once it's in and you open it up ever after, it will be available. And then back here in the code, doing the same thing with the edges, pulling that data from the data key value into the higher level. And then same sort of statement, we're going to go through each of those objects. And this time we're going to find the two nodes with the IDs that are listed in the edges definition, pull those up, and then call a different APOC API to create a relationship between them. And that's all the upload function does. All right, so we can actually show this off. So here we've got our interactive app again. Okay, from here, let me show you that we have an empty database. Okay, no changes, no records. And then I'm going to go back here. So I'm going to pull the Star Wars entry from Wikipedia again. I'm just going to paste this in here. Then press extract network graph, which will kick off the BAML process. So that's over here, right? Extract network graph. Here we're going to pull the information using BAML, upload to Neo4j, and then put it into the session state. And then once that session state is populated, Cytoscape plugin will display a graph. Cool. All right, so we can see here that it looks like it worked. And I can also double check to make sure it's in the Neo4j database. And let's take a closer look here. All right, Luke Skywalker learned from James Earl Jones. Oh, Princess Leia was rescued by Luke, and he went on a mission to Death Star. So mostly correct, this bit about learning from James Earl Jones. All right, so the last thing I want to show is this one extra button I added here just called loading graph. So this is just going to take existing graph data from a Neo4j instance and then visualize that. So here it's just calling a download Neo4j to Cytoscape function, and that is also in this new class here. Its arguments are, again, the credentials, and here you could optionally specify specific nodes and relationships to pull in. Again, I built this originally as a more general purpose function. In our case here, we can just pass it nothing, in which case it's just going to pull all the nodes and relationship types. Okay, so it grabs all that, and then what it will do, it then take that information and parse through it and construct a dictionary object that matches the Cytoscape JSON format, right? So it'll create these node dictionaries, create the edge dictionaries to match the schema format of Cytoscape JSON. And then it will return this larger payload that includes the elements. These extra keys are used by Network X. So in our case, it will just ignore this information, but again, it is kind of a general purpose function. All right, so this is one way to use BAML to take unstructured data, whether it's text, images, audio, convert it to an intermediary JSON graph format, and then push it to Neo4j for persistent storage and also for pulling it back in to provide data to a client application. In this case, with Streamlit using Cytoscape. Okay, hope that was useful. Thank you, and I'll see you in the next one.